So, good day everyone. Today I will be presenting our laboratory activity for Integrative Programming and Technology 1 entitled Mini System Integration from the Data to Functionality. So, the purpose of this activity is to demonstrate how separate software components can work together using an integration model. So, inspired by my interest in astronomy, particularly moons, I developed a planet and moons information system that demonstrates system integration using real programming language, a real programming logic. So, further, we'll discuss the system overview first before we demonstrate our system functionality. So, this system is composed of two subsystems that operate independently but share data. So we have subsystem A and subsystem B. The subsystem A is the planet data provider. So it manages all planet data, including the planet name, the type, the number of moons, and a short description. So the data is stored in a structured text file called planet.txt, where each record is separated by commas. So subsystem A handles data initialization, data storage, retrievals, and deletion. Whereas the subsystem B, which is the consumer navigation system, it is the planet navigation system, and this subsystem serves as the user interface of the system. So it allows users to search for planets and add custom planets, delete existing planets. So subsystem B does not directly manage the data. Instead, it consumes data provided by subsystem A. Moving on, in this system, we have been able to choose what integration model are we going to use in our system. And so, the integration model used in this project is data integration. So, subsystem B accesses structured data produced by subsystem A through a shared data file. So this approach is similar to real-world systems where applications integrate through shared databases, files, or APIs. Now, let's go deeper to the most important part, which is the system demonstration. So this is to test if our system really works. Now here, we will try to run the program first and to see the function of this system. When the system starts, the main menu is displayed. So we have a menu to search a planet, add custom planet, delete planet, and of course the exit menu. Now, first, I will demonstrate the search planet feature. Let's input 1 to search the planet. So let's say enter planet name, let's say Earth. So here, as you can see, the system successfully retrieves and displays the planet information from subsystem A. So those content that has the Earth, the type, the moon, and the description was stored in the subsystem A, which is the planet data retriever. So another one, let's search Jupiter. So here, so those data comes from the planet data provider. So the data was stored in the planet data provider, which provides all of the name, the type, the moon count, and of course the description. Since we are done demonstrating the search function, let's proceed to the next function, which is to add the custom planet. So let's put 2 and of course the planet name. Let's say Pearly. And the planet type, let's say terrestrial. And the number of moons, let's say 10. And for the description, let's say a pretty planet. So as you can see, there is a message which that indicates that planet was already added successfully. Now let's search about it. So here, so it was really on the system. So it was already saved in the planet text, which is where we store the 9 planets too. So the new planet is saved into the data file and can be searched immediately. As you can see, it has already been recorded. And for the last main feature is to delete existing planet. So let's input 3. Of course, we are being asked to what planet name should be deleted. So let's say Pearly. So it says that the planet deleted successfully. And here, let's take another planet to be deleted. Another is Earth. So it says here that the planet deleted successfully. So that is how those menus work. So as you can see, the system successfully removed the custom planet called Pearly. That means that both subsystem really work. So the system removes the selected planet from the data source, ensuring that the deletion is reflected immediately. And also, last to the menu list is the exit menu, where in the program will be exit as long as we choose the option 4. And also, let's also present the planet navigation system, which is the subsystem B. This is where we navigate the system. Further, in another subsystem, which is the subsystem A, and it was named as Planet Data Provider, which provides all the data while we navigate the system. So all of the 9 planets was stored in the Planet Data Provider, or the subsystem A. Let's just a quick review. Since we are done demonstrating the system in this time, I will share some challenges and also my reflection on making the system. So one integration challenge encountered was ensuring consistency between integrated components. A method mismatch between the subsystem initially caused the delete function to fail, so highlighting the importance of interface consistency. Another challenge was handling persistent data, where existing files prevented new initialization logic from running. So these challenges reflect real-world integration issues commonly found in data-driven systems. So this system reflects real-world application such as the inventory systems, enrollment systems, and information portals. So the same data integration principles used here can be applied using databases, APIs, middleware, or microservices.